Viewers, now we discuss and important topics, especially used in DL analysis. That is a property of Jacobian. How to use the Jacobian in functionally. That's basically the parts of functional dependencies, and how to use it with the help of a problem we will discuss. If g0 is equal to 0 and g dash t equals to 1 by 1 plus t square, then prove without using integration that gw plus gt, that will be given by g of w plus t by 1 minus wt. We have to prove this. Now to prove this, let us consider y will be gw plus gt and z will be w plus t by 1 minus wt in this way. Let us take, and then we calculate the Jacobian. So Jacobian of, that means del of wz yz by del of wt, that will be the definition of Jacobian: del y del w, del y del t, del z del w, del z del z del w, and del z del t. Now it's clear, del y del t, that is g dash w, and del y del t, del y del w g dash w, and del y del t will be g dash t. Now here dj del z del w, from this we are using the derivative of u by v methods, simply using 1 minus wt whole square. It will be 1 minus wt into derivative of this, so it will be 1 plus w plus t into derivative of this with respect to w, so that will be t, minus of t, that is plus of t, and here also the same cases, calculating the derivative. Now after calculations we will get these results, and after breaking the bracket, wt will be cancelled. We get 1 plus t square by 1 minus wt whole square, here 1 plus w square by 1 minus wt whole square. Now we are using the property, here it is g dash w and g dash t. Now substituting the value of g dash w from the given conditions, that is g dash w, that is 1 by 1 plus w square. We substitute it, so it will be 1 by 1 plus w square, and it will be g dash t, so that will be 1 by 1 plus t square, and here it will be same. So after baking, it's clear that result will be 0. No problem for that. If we calculate, 1 plus w square will be cancelled from both the sides, and here 1 plus t square also cancelled, so finally we get 1 by 1 minus wt whole square minus 1 by 1 minus wt whole square, so that will be 0. So we can conclude they are functionally dependent. So hence we can say y and z are connected by a functional relation. Since they are functionally dependent, there is a functional dependence relation. So functional relation will be taken as y equals to psi of z. Now our object is to prove that the function g is equivalent to phi. So y, it's clear that y will be gw plus gt equals to psi of, substituting the value of z, that will be w plus t by 1 minus wt. Now putting t equals to 0 and using g0 equals to 0. So t equals to 0, that will be g0, g0 will be 0. So gw will be equivalent to, here t is 0, psi w. So we can say that easily g is equivalent to psi, which shows that gw plus gt, that will be substituting psi in the place of g of w plus t by 1 minus wt. Hence the proof is complete. So in this way, here we are using the property of functional relation, that is a functional dependency. If Jacobian vanishes, then we can call any function, there is a property of functional dependency if Jacobian vanishes. So in this way we are getting some idea with the help of a problem how Jacobian works in cases of functional dependency in real analysis. If you like this video, then like it and share it and subscribe it. Thanks for watching.